Okay, so we have, in the confidence interval section, there's 3 confidence interval formulas and then the 2 for finding sample size, right? So on that quiz, that quiz 5 that you guys took before, there's that question 1C that was all about finding the sample size you need. When I ask you, like, how many would you need to survey to be within? The thing you don't know is n. So you probably want to find a formula that's got n equals, so you can figure out what it is. So the confidence interval stuff, this guy here, and then the exact same formula, just in a slightly different situation. And then this guy, the one that we created, we created the formula for it. Right, make sure this is a Q there. Okay. So if I ask you, create the confidence, or create the 95%, the 88%, whatever percent confidence interval, you know it's going to be one of these 3. It's the plus or minus. That's why it makes an interval from small to big. That's what an interval is. And that's one interval. It's not intervals. 5 to 7, that's an interval. So this is all stuff from that chapter 8. And then you have these 2. Let's do this one first. And of course, if you only have S, what do you have to use when you only have S? You have to use T. So if you want to, it really is the same formula, but if you want to, you have that formula. It's the formula I had down on that quiz, trying to be a hint for you.
Are those all the formulas used for the test?
No. I'll just stop for a second. So this is the stuff from the chapter on confidence intervals. And then we got into the stuff about hypothesis tests. I really didn't introduce anything new until we got to the z-score for percentages. So I mean, the very first thing, if you want to put down the same stuff. And then if you want to remind yourself that in the case we're using t-scores, you still have to do this, right? So, of course, this is related to that 4th step where you try to see how far your sample got. Right, 3rd step, how far do I have to get away to show evidence? 4th step, how far do we actually get? That's what these do. That's the look on your face. Let's see. Before I get into chapter 10, was there anything specific from chapter 9 besides these? I don't think so. And then chapter 10 gave you this behemoth here. So, guys, if you really want to be nice to yourself, you could even put, like, parentheses in there. So let me get the formula correctly, and then you put it in the calculator incorrectly. Calculator knows order operations, which kind of sucks for the people that just want to put it all in there. If you don't tell the calculator this is the top, it's not going to know it's the top, and it's going to do it division first. And you get funky answers. So you do it over here too. I like it. Can somebody tell me which one of these is the formula for a test for 2 populations? Yeah, the last one. The one's got 2 things happening. I love it. And it just doubled everything that was in the normal formula.
The last one?
Yep. Everything's been doubled over there because I got 2 samples to take because I have 2 populations that I have a claim about their relationship. I like it. So chapter 9 is a little bit, it still happens. You still have a known mean, and then you take 1 sample and compare it to the known mean. But what happens more often is you take 2 samples and compare those 2 samples to each other. Anybody have any suggestions on any other formulas that you think should be up on your formula sheet? You can bring all the old formula sheets. Make sure you didn't lose any points on those before you use them again. You can bring them all with you.
So we can't use a formula sheet? I just got here, so chill.
You were here a second ago, Jackie. I said you can use all the formula sheets you've made this whole semester, not the one that's made for you.
Oh, okay.
Yeah, you can't use the formula sheet from the insert from the other book. It's got way too many words on it. It tells you what the formula is, what it's for. No.
Wow.
Aw, you cry.
I'm still good.
Little tears. All right.
Maybe I don't understand.
Any other
This one's very
formulas,
helpful.
Jack? Any other formulas that you think should be on here from chapter 8 and 9 and 10? All right. I like it.
The
Okay.
E, the air.
Yeah, it's actually up here, but if you want to put it specifically, I mean, what part of these formulas is the error?
The whole thing.
No.
I mean,
Yeah, after here. So the error would be this, give or take that piece must be the error. The way I say it kind of makes it apparent that it's the error. This, give or take this much. That's how much I think I'm off by. So this is the error. So if you want to put next to this, error equals that, error equals this. Yeah. Error equals. No worries. Oh, I did forget one z-score formula. Let me help you guys out. It was the one for when you're testing a claim about percentages. That was the one where we stole this guy and made it, realized it was a standard deviation, so we just use it down there for the z-score. Yeah.
So which is the one you need to use to figure out how big you want your population to be to get a certain error bound?
What's the letter you would use? Well, it wouldn't be a population, right?
The N. I don't know.
Yeah, so it's probably the formula of one of these guys that's got n solved.
Can you use any of them?
No. Well, depending on the situation, of course. You use the correct one depending on the situation.
So it would be one of those 3?
Yeah. So if you're talking about how large a sample to be within so much percent of the real percentage, you probably want to use the one with percentages.
Okay.
Yeah, and the one, if you want to be so much to be within so much of the true mean, well, means come with standard deviations. You probably want to use the formulas that have standard deviations.
Right.
Yeah, these are both the same formula. I hope to God somebody in here kind of sees what I mean. A measure of how far away and a measure of the spread. Bless you. Bless you.
thank you.
Just that's an approximation for this. Bless you. And T is the score that kind of covers your butt for that situation where you only have an estimate. So they're really the same formula.
What about the
You
one
get a
that
shot for
you
that,
put-
for the being allergic to stats.
What
What?
about the one that you put 0.25? Like,
Yeah, again, so this guy, if you don't know what p hat and q hat are, and somebody help me out, what's the symbol p hat mean? What's that reference? Sample proportion. So it's a proportion from a sample I took. If I don't have those, what's my best guess for them? What's my best guess if I don't know what the value of p hat is? What's my best guess? 0.5. And what's 0.5 times 0.5? 0.25. So there's a formula that's got a 0.25 here. It really just relates to, so yeah, okay. Do you want to put that formula down?
if you don't know p hat.
Bless you. What's that?
What? I don't know. This guy. I have a dumb question.
Okay. Was Who said? You said that?
Yeah,
Go ahead.
but, like 101, not 95.
Oh, okay.
The value.
Yeah, okay. All right, guys, so now we can do something. So I just had a request to do an example from number 10. And, I mean, the one that was on the practice test was number 6.
Yeah, number 6, the formula we used for that one, the one on the bottom right.
Yeah, that last one, yep.
Last one.
Cool. Because it's got 2 samples. So I want to use a formula that's got room for 2 sample information. So to do this one, it's referencing number 3. You guys have all these here yet?
Yeah.
Still working? Okay. I'll move over here.
Show me how to do them 3.
Well, number 3 is just plugging that stuff in your calculator, doing 1 var stats.
So I plug the first class in, and after that I plug the second class.
Yeah, the first group. So the first group where they passed the class. Yeah, so you put that into L1. You do 1 var stats. Put the failed the class in there. Do 1 var stats. You can put it in L2 if you want to. Do 1 var stats on L2. I like it. And then to make the confidence interval, right? So if I want a 95% confidence interval,
So I do 1 minus.
yeah, you got to figure out the degrees of freedom. 95% confidence. You got to figure out where you would look on the t-score chart for that. How many tails does a confidence interval always make? 2. So 95% confidence would be 0.052 tails.
And this one I'm looking at the
For those who pass the class, what's the sample size?
So we don't use that equation?
Well, right now I'm doing number 3. Mohammed asked me about number 3, and that leads into the other question they had about number 6. I think it references number 3. Yep. All right, let me try this again. I had a question about number 6. It references number 3, but then somebody asked me, can we look at just number 3 at first? And it made sense, because we have to do number 3 first a little bit to help us get number 6 going. So number 3, I do have 2 samples, but I want to create a confidence interval for both. I like it. So for those who pass the class, what is N? 16. So what's DF? 15. And then you know that it's 0.052 tails. Degrees of freedom is 15. Those who failed the class, the only difference is going to be the sample size, right? It's still 0.05.
How do I know it's 2 tails? Because it's 2 samples.
Nope. When you make a confidence interval, what does that look like? The homework had you draw several of these.
You usually give us
Huh?
so you usually give us like the number.
No. Screw that. It's an idea. It's an idea. When I make a confidence interval, how many tail test is that? I want to catch the what. What's 95% confidence mean on the picture? What's that mean? 95% where?
In the middle.
Middle. So the minute you try to designate the middle, how many tails do you create? 2. So it's always a 2-tail test for confidence intervals. Yeah. Yeah.
I was a little confused about this. Even for a T-score, you can draw that same.
T-scores only are usable when I have an underlying normal distribution. So they kind of change the shape of it a little bit, but they require an underlying normal distribution. So I can still draw the same picture. I mean, it's got a little bit different slope and stuff like, but we don't get anywhere near that detailed. Yeah. I like it. So what do you guys get? Anybody trying to look at that t-score? 2 point? Yeah, 2.131. So C, 2.131. What part of the formula actually tells you it's a two-tail thing? There's two directions, plus or minus, right? I start at the middle, go up, and I go down, so that's two tails. I like it. Sound effects or not?
Yeah, use information from them. Oh.
So we're looking at number 3 first. We're not doing number 6 yet. I'm looking just at number 3 first.
You're so hurt.
Okay. And now you got to figure out, if you do 1 var stats, somebody tried that yet? And figured out what X bar for the past class?
7.631.
Yeah. 7.6, oh yeah. So I put 7.63. What do you get for S1?
1.14.
Say again?
1.14.
Nope.
No? 1.14.
Wait, 146, is that it?
1.146, yes.
That's what I
Is that what you
said.
said? All right. That's not what I heard.
Oh my God. You didn't want to know.
No, I want to hear what you mean, especially if it's right. So you got to speak up. I can't hear. And now to create the confidence interval, I just have to use the right formula. And I already know which formula I'm using because we already know we have to use t-scores. I only have S, right?
Can you also use N?
Say again?
N.
We know what N is.
16.
Yep. So which formula are we using? The second one, yeah. This guy.
You didn't use that one? Because you didn't use it.
Again, we're doing number 3. Not number 6 yet. Yes?
Well, number 3 is for 2 populations, so why are you using that as opposed to 2 populations?
So what did number 3 say to do?
Oh, for each of the populations.
It's a normal.
All right, it said create a confidence interval for each of the population means. Yeah. Okay, and then I just have to plug and chug what I know in there. Check.
What?
Quiet. So then if I put this in, I get 7.63, give or take. T-score 2.131. 1.146 divided by square root of 16. All right, and to do the fail the class would be the same thing. Will the t-score be the same for fail the class?
Yeah.
For that group? Will the t-score be the same? No, because what's different for the people that failed the class, that group, that sample? It's different n. And it's 14, degrees of freedom will be 13, you'll get a different t-score.
So you basically just do that for one and then do it for the other, and that's it.
Yes, because that's what it said. Create a confidence interval for each population mean. Cool, I like it. Is that decent? I mean, now you can figure out the error. You add it, you subtract it, like you always do. So the only new thing about that problem, it's not new, is I gave you a list of data. You had to calculate your own sample mean, your own S. You had to calculate it yourself. It's the same formula. There are several homework problems that had you calculating your own stuff. Yes.
I got 7.11 and 8.6.
For those who passed the class, I got 7.02 and 8.24. What'd you get for your error?
7.11 and 8.
No, just for your error, just for this piece.
0.62.
Oh, okay. Oh, it should be 0.61, right? So at most it'd be 0.611, because it's 6105, yeah. But you know, it's not that huge of a difference.
I have a question.
Let me, all right, I want to. All right, so I want to say something. So it feels, all right, so it feels like there's a bit of a atmosphere in there that I've been combating for a while. I don't understand it. I've never had it before. I love statistics. I think, there's no good way to say that, but I think a few of you came in less prepared. Some of you guys think you're doing the homework, but you're actually getting the answers from somewhere, so you're not really doing it. So you get worse grades than you want to. Some of you guys come to class and then leave early or don't come to class. Some of them are not hearing this because they're not here, right? So I don't know if I'm just hoping that I'm not doing something different myself than I normally do, because it's a very different experience this semester with stats. I love statistics, I really do. I think you guys can see that. Some of you guys maybe just discount that. You have to take this course for some reason, right? There's something that's making you be in this class right now, correct? Some of you guys might be taking it just for transfer, and you're going, man, I wonder what 120 was like. That's possible, right? But normally people take it because it's in their major. Because if people are going to take one for transfer, they take the lower number because they just think in order, right? So they take 120. So I don't know. I just had to say something because I don't like it. I'm not sure what to do about it. There's a few students who like to make non-constructive comments. I don't want to come down too hard, but I need to keep things going. I'm trying to teach to the people that are really going to get something out of this. I want that to be everybody, but I can only meet you a certain distance. You have to come there and meet me there too. I don't know if you're used to... So this class is difficult because of the ideas. And if you don't think about the ideas, you're not going to pass this course. This is not just just tell me where to put the numbers and get the numbers and put them down somewhere. That's not... I think by this point you guys know that. There's a lot more to this. Anyway, I didn't know what to say about that or what to do about that. It's just this, to me, it feels like a reality, and I don't like it. And if anybody wants to come by and give me suggestions on whatever, if I'm not doing something correct, if you want me to change like how I grade or something like that, that's not going to happen. Because I've been grading for a long time. I'm grading the exact same way I was doing over the intersession in the last semester. That's not different. That's not changed. Okay. Just not as many of you coming by to see me in my office as probably should. If you're going for tutoring, are you sure that the tutor is doing this the right way? Sometimes you get tutors that are a little new and they just want to do well, so they kind of give answers, and that's, that makes you feel, it's sort of like finding your Christmas presents early. You're like, oh, cool, and then later you're like, oh, shit. Right? Day of Christmas. Oh, I already knew I was going to get that. It doesn't help you at all. Anyway, I'm sorry about that, if that made you uncomfortable or whatever. But I need to address it. I don't like that feeling. I want it to be something. I'm not against you. It's not my purpose. I get a feeling like some of you guys feel like I'm against you, and I don't know if that's true or not. It's not true. So, anyway, all right. So again, like I said, if you have suggestions or thoughts about that, let me know. So who had... Yahtzee, you had a question?
Me?
Or somebody?
It was
Jackie?
4C. I don't know if it's right, but I got a negative number. Negative 1.645.
I mean, it's possible to get a negative number, of course.
Yeah.
That's right.
Yeah, because it's a one-tailed test below.
C.
Yeah.
That's why the tutors.
Yeah. Uh-oh. So tutors can make mistakes. I want you to realize something.
He was fighting with
I'm not
me,
making
no.
I'm not making an excuse for tutors who don't try to look up the right answer or get the right information. The tutors that tutor here normally how many stats levels do we offer here? 1. Normally, if you're tutoring algebra, how far past algebra have you gotten? Very far past algebra. So you're tutoring these things you've been using forever, so you really know them backwards and forwards. Now, the tutors who work here, they have to go through training and retraining and recertification, but it's still just based on that one course. Most of them haven't gone beyond that. So I'm not saying that you shouldn't get a good experience from going to see a tutor. I'm saying that you need to realize that they're not used to the different book. They're not immediate with some of the concepts. You got to work with them. So did you have a question, Jackie? Or?
I just want to know if I was right.
Oh, okay. All right.
When we're seeing the conclusion for the confidence interval, where do we put the unit?
Oh, well, I was giving credit to people if you should put it right after the number. But, for example, if you said something like, we're 95% confident that the interval 1 to 2 contains the true grams of something, okay, at least it's somewhere. But they really should come right after the number. If it's a percentage, don't put it in decimal form, put it in percent form. That's kind of like acts like the units, the percentage. Yeah. What about, so we haven't talked about number 6 yet.
What should be our conclusion then?
For the one we just, right here?
Yeah, because we have here, it is known that our new results support the idea that information means are different.
Oh yeah, so then you have to step back. So when you make your two intervals, this one, I'll just give this to you. This one should come out to be like 7.02 to 8.24. And then the one for those who failed the class should come out to be, where'd it go? 4.07 to 6.07. That's the number of hours studied. If these indicated that the population means, the populations they're describing, those who passed the class, the entire population, and those who failed the class, that entire population, if those means were the same, then what should these two do? What should these intervals do that they don't do? They should overlap, right? So if the means really are the same, if the means really are right there, mu1, mu2, they're really in the same place, then more than likely, not always, because there's always a chance that our confidence interval isn't right. That's why it's only 95% confident. It's a bit of a chance that we're wrong. But if I make intervals, they should overlap, especially if the means are supposed to be the same. So when the intervals do not overlap, that is evidence, not proof, evidence that the means are not the same. Because this is not how you really interpret this, but this looks like the mean could be at most 6. And here the mean could be at least 7. So could the means be the same? No, not from what we see. Is it proof that they're not the same? Of course it's not proof, because there's always a chance we're off a little bit. Not because we calculated incorrectly, but because this is based on samples. And samples can change quite a bit. All right. So this all came out from asking about number 6. So we put down here, this is for the pass the class. Get rid of this here. And then for fail the class, where do I put you? Oh. N2 is 14. X bar 2 is 5.07. S2 is 1.731. All right, so to talk about number 6, we have to know all these. Right? So talking about number 6, it says, do a hypothesis test on the claim that the means are equal. We already saw that the confidence intervals seem to say that they're not, because they don't overlap. So our hypothesis test more than likely should say, reject the claim that they're equal. We got to go through it. And it gives me an idea of how certain that rejection is, how significant it is. So for number 6, what is the claim? No, that's not the claim. Yep, the population mean, so mu1 equals mu2. Cool. Now I'm going to kind of skip down to step 4 real quick after this. All the steps are basically the same as before. That's going to be which one, HO or H1? HO. 50-50 shot on that question. It's HO because it's got equal sign. Right? How many tailed tests will this end up being? 2, because the opposite has not equal to. There's 2 ways to do that, up or down. So that's step 1. Step 2 will be, can you use Z or T? We definitely have to use T. We already know that from number 3, but why am I able to do anything? Well, why was I able to do number 3? Because it actually says they are what? What? So number 2, why am I able to use T-scores? Sigma unknown, and it actually states distribution is normal. So a lot of you guys focus on this, which is awesome, if you remember which standard deviation tells you which thing to do. But you also have to tell me why you're allowed to do anything. So you got to say 2 things here. If it was a percentage problem, what would you have to check here? 2 things. You have to check what things. And that's for means, for percentage, and P. And then Q have to both be at least 5, yeah. I like it. Same idea, just checking to see if it's normal. Third step would be what's the rejection region. You actually use the same T-score we used over here, which was there, 2, 1, 3, 1. Or actually, it's the other one. This one had the smaller. So remember, when I have 2 samples from 2 populations, how do I tell what my degrees of freedom is going to be? I base it on which sample, or what do I do? The smaller one, right? I base it on the smaller one. So the degrees of freedom in this case would be 13.
Wait, use a smaller sample?
Yes,
Okay.
I like it. And I think that was, whoops, here it is, 216. So, I mean, every step is the same as was from chapter 9, every step. The 4th step is the same, though the formula is a lot bigger because you got more stuff to put in it. So it's still, what am I talking about? What can I use to talk about it? What's going to show enough evidence? And then did I show enough evidence? How far is far enough away? How far away did we get? So that's where we're going to start throwing stuff into that big-ass formula over there. So it would be 7.63 minus 5.07. Square root of. And the big mistake is people forget to square these little dudes down here. It's still a T star. It still means the same thing. It's just bigger because I got to have both sample information in there. So it's really seeing how far apart the samples are. If the populations really are different, then any samples taken from them should also be decently different. So really it's just trying to see how relatively different are these samples that we took.
When you write in the calculation, you have to put the 2 inside the parentheses?
Yeah, if you put the whole thing in
outside?
at once, you got to tell the calculator what the top is. And then the bottom, if you have a parenthesis, don't close it till the end, or you got the calculator that just grows the square root, make sure that all the stuff is inside of it.
Because I put that like separate, and I just put like big parentheses around it, and just put a 2 on the side. Trying to get the same outcome.
No, I'm not sure what you mean.
Never mind.
You square this whole thing?
Yeah.
Is that what you're saying? But that won't be true, because you don't square this. If I put a bigger parenthesis, it would be foiling that out. Doesn't make it the same.
Oh.
Yeah, a squared plus b squared. not equal to a plus b squared. Right? So yeah. Okay.
I just wanted to get it over with.
So I mean, you would throw that in the calculator, see what you get. I've got that on the answer key, but is there a question as to the approach?
I have a question on 3, which is related to this. It says in parentheses, it is known that the populations are normally distributed, so that's how we know for this one?
Yep.
Okay.
Cool. Since it's using the same data, I know the same things about it. Yeah. That's right here, states distribution normal. Yeah.
So it's a yes. Oops.
What about number 7?
Yeah, let's do number 7 because I didn't actually put that on the answer key. I ran out of room and didn't want to do another sheet. Number 4. Who remembers type 1 error? What is that reference? Type 1. There's a short phrase and a longer phrase. Type 1's the short phrase. Yeah, reject a true HO. Think about it. That's obviously a mistake, right? That's an error. If the HO is true, but I reject it, that's a mistake I made. There's no way in general I can know that is a mistake, but that is a type of mistake I could have made. So reject a true null. What was a null for number 4? So if you do number 4, the claim was that the mean is less than 16.1. So which one would this be? H1. So what's HO?
Less than or equal to?
Greater than equals. Because that's already less than. All right, so that's the null. So if I reject a true null, how would you state the error then? We think that it is less than 16.1 when actually it is at least 16.1. I mean, is that straightforward? How would we be wrong? If the null is true, this is the reality. The mean time our drug takes to bring relief to headache pain is at least 16.1 minutes. How would we make a mistake? We would think that that's wrong. We would think that it's actually less than 16.1 minutes. So we feel it takes less than 16.1 minutes, when in reality it takes at least 16.1 minutes. That would be an error. That would be a mistake. Then we go on TV, make all these claims, all these ads. People would take the stuff, and over time people go, well, this shit sucks. The other drug was fine, right? Okay. So that's a type 1 error. Reject a true null. You say, we think this is wrong, when in reality it's right. That shows you that it's an error that I made. That's it. That's it. What is a type 2 error?
To reject. False.
Yeah, you can reject. When would you be wrong then if the thing you're rejecting is true? Or you can fail to reject, and when would you be wrong? When the thing you fail to reject is false. Fail to reject a false. No. So there's a lot of different ways you can say this. So what's actually true then? The null is false. So what's the reality then? It actually takes this is wrong, therefore this is right. So a nice way to say this is, it actually takes less than 16.1 minutes for my drug to relieve pain. But we think that it takes at least 16.1 minutes. Poor us. We don't put the ad out. People don't get that better drug. Too bad for us. To be honest, on the surface of it, if you come out of this class understanding that any study you see, there's a chance that it's wrong, and you want validation, you want somebody else to replicate that study, or in the study they better say they already did this over in Sweden or somewhere, and they got the same thing we did. You go, oh, okay, now I believe it more. There's still a chance that it's wrong, but it's really small chance now. So don't just take everything you see in surface value. Say, did you guys look to see if anybody else did this? Has anybody else tried to do this? Maybe you guys just got lucky. I don't know. I'm going to take your drug until I see more than one study. Yes?
So when we are identifying the error, we always still need to address both the null and the...
No, it's your choice as to how to word the error itself.
Just say, you know,
You could totally just reference this. You could say, we feel that it isn't at least 16.1 when it really is for type 1 error, right? We feel it isn't this when it really is. And this one would say, we feel it is this when it really isn't. But it's just, it's English. You can say it a lot of different ways. That is the opposite of this, so you can reference this if you want to. Yeah.
Wait, so you could write it literally like that. We feel it is what the null is when it is not.
Yeah, so if you type 2 error, fail to reject. So we feel that this is true when in reality, it ain't.
Okay.
You can use good grammar too, but you don't have to.
Back to type 1 error, it would be, we do not feel.
Yeah, we feel that this is wrong when in reality,
It is.
it's right.
Okay.
Isn't that an error then? And isn't there only 2 things we do? We reject it, and when would that be wrong? It's right. Or we fail to reject it. When would that be wrong? It's false. There's only 2 things we do, right, with a hypothesis. We reject or we fail to reject. That's it. So that's why there's 2 types of errors. Because you can see when we would be wrong in each of those situations. Okay. What's up?
I don't remember what I just said. You feel it is.
I got you captured. You can
Oh, God.
watch.
4253. Okay.
There you go. Get the timestamp. Get in there. Yes?
So for the number 4, it is one test.
Yeah, number 4, totally one-tail test. Because the claim has, I don't know what to put it, directional symbol, right? Less than. Please understand, I'm not going to bold the phrases on the actual test. Right?
Thanks.
Rude.
It seems to not help some of you guys anyway. So, we'll see. Maybe you'll be better if I don't. Yeah, I have to address the person that just said rude. When it's really just normal. I love you guys. I don't believe you don't just give us a practice test again for the actual test. Oh, shit. All right, you guys, let me give you guys the answer key, see if that spurs any more discussion. You don't have to. There's not 2 samples. So you don't have to use a big form. There's 1 sample with a claim against the known mean. All right.
Because I realized that I switched and I did like this. It's a C-square. I put it yeah, like I switched because I didn't mind step by step. I didn't
I had to squeeze 2B in there after the fact. I realized I skipped it. Oh. Your one's not written on there.
Thank you.
Mhm.
Do you have like any of the other worksheets from the past on you?
Oh, let's see. I mean, I've got. Here's one for proportions. I don't think I gave one for like chapter 10. I think we just talked about it. There's T-score practice. I don't know if you got that one, yeah? You got that one, right? Yeah. Okay. I think you're caught up. Or at least as far as what I got. Yeah. Okay.
Okay, I'm confused about this. I don't know why. I know you use a T-score when it's a sample, but when you're reading through it, why is number 4 a population not a sample?
No. So there's a sample that was taken in number 4. The standard deviation that we know is which standard deviation? Was it from the sample?
No. Was it?
That's a key word. Standard deviation for all.
Oh, okay.
Yeah, that's the population standard deviation. Yeah.
So then you do Z-score.
Yeah, so it's not did I take a sample or not. We are going to take a sample. It's is the standard deviation that I'm going to use the sample one or
So
the
then it'll
population.
either say like sample standard deviation or standard deviation.
Or no, I'll just say we took a sample of 48. We saw a mean of this and a standard deviation. That came from my sample. There's like a separate sentence. I'm trying to make sure you understand. It's not from the sample. You see what I'm saying?
Yeah.
Okay.
I make a correction and can you help me to check this right?
It sounds familiar. Do we have a Z-score? I mean, as long as you looked up correct on the Z-score charts. Here we go. Yay. So it's 0.07. 0.07. 1.48. But it's not negative because it's a right-tailed test. Right-tailed test. That's a left-tailed test. So right-tailed test, same number positive, right?
So it's 1.4.
Positive because it's above. It's on the right. Yeah.
Thank you.
Mhm.